Hi guys, I'm doing a video today about the hydraulic calculation software, Fire from Elite Software. And I'm going to go ahead and I've got that open here. I'm going to press a button and I've got that up and I've got my CAD program up. And some of you who have taken my boot camp will recognize this is our ranch home for our CAD Basics boot camp. And I've got it set up here with, this is just a made up house with a made up address. So we just put it 30 feet off the street and drew an underground here. We just kind of put, common underground for our area anyway. A lot of times they'll have 10 feet from the city main to the meter out of 3/4 inch copper, and then it will go from there to the house in 1-inch PVC or, maybe 1.25 PEX, 1.5 PEX, that type of thing. They might want to do 1-inch PEX, but that usually will not work with the sprinkler system. 1-inch PEX is a much smaller internal diameter. But I don't want to get carried away. We're talking about fire, so let's just get into this. I just have this set up with some nodes to calc, and we get a lot of people interested in fire from Elite Software, and so we're just going to run through calcing our 13D system with that software. So I'm just going to click on, let me see, new button right here, and it's just going to ask us for project information. This is basically stuff that's going to go on the cover sheet. And so I'm just going to put sample ranch home, designed by, apparently I can't tab between boxes, that's annoying. Designed by Colby. Jeez, I could spell Colby. And today's date, we'll go with, we're still just barely in the 2019 NFPA 13D here in Oregon, at least for a few more months. All right, and we'll just pretend that we are submitting to Portland Fire and Rescue. Why not? Just picking a jurisdiction that we have over here. All right, now we've got client data, company data, building data. I mean, I guess depending on the situation, you might have client data that's separate from these, but I'm just going to go, company data, super good guy, sprinkler pros, I don't know. Representative, Joe Blow, pipe fitter, that's his official last name. Let's just move on. Building data, on this one, it's the sample ranch home for our project, but normally we would put like on a residence, it's usually the homeowner's names, this is, first name sample, last name ranch. This is the sample ranch residence. Contact at building, Bob. Address of building, 1, 2, 3, 4. No name lane. City Boring, Oregon. 97009, I think, is out there, but there's no, this isn't a real place. I'm putting too much time to this. Okay, this is just generic information for your cover sheet. You may or may not need to go into a lot of detail with this. All right. Now we're getting into important stuff here. We're doing a 13D sprinkler system, so we're not going to be, there's nothing to do with in-rack sprinklers. We'll just skip that. Inside hose streams. We can just skip that. But if you, inside or outside, I'd probably put in outside hose stream. if you had to do your 5 GPM for a duplex, or if you're in California, you just gotta have to do it everywhere. You could put that right here, put the 5 GPM. I'm not gonna do that though, because we're doing a pretend project in Oregon. Default pipe material. Now, okay. Type of pipe, we've got a bunch of options here. Let's go to, I think it's 13 is Blaze Master CPVC. That's what we'll predominantly be using. That's one of the defaults in here. All right, now default K factor, we're going to be using a 4.9 sprinkler, but that's not in here. But I'm just not going to worry about it. You don't have to worry about well, why not? Let's just put it in, because I want to show you you can press. When we get to that point, if you have something in here, you can type D for default. So we'll put in a 4.9 K factor. That's what we're going to use. Sprinkler model, we're going to be using a Senju. This down arrow just gives you a little information about what goes in here, but you just type in your brand. The same thing with this one. I think it's an SS8464 if I remember right. Temperature ratings on those are 162. Sprinkler size is a 1/2 inch. If anybody's wondering how I got the 1/2 inch symbol, I'm pressing the Alt button on the keyboard, and then as I'm holding it down, I'm pressing 0189. That's how you get that symbol to pop up like that. You know, it's not necessary. It just, I think it looks a little nicer on when it prints it out on the report. I always do it in CAD that way as well. Labor rate, these things, you know, it really, in order for this to even matter, you would have to enter all of the heads in the system, even the ones you're not flowing. So it really doesn't make sense. It must be auto saving. I did not hit save. Let's do that after a certain amount of time. Let me just, I'm going to click on this old one and just add a 2. All right, we lost our info. Let's get it back. Let's see. General product data, system data. Here's where we were. All right, so like I was saying, this labor rate stuff, these 3 boxes, none of this is going to do anything unless you enter the whole system. That might be worth it for you. But I think it seems like it'd be easier to do the same type of estimating with the spreadsheet. I don't know. Anyway, moving along. Primary type of discharge, you know, it's just going to be a sprinkler. If we were doing a standpipe calc, I suppose we would be changing that to hose. It does behind my head. Let me see if I can move out of the way. This comment box, you can type something in here, and if you check this box, it'll be included on the printed out report. But I'm not sure what you would use that for. You might have a reason. Hazard description, it only has options here out of NFPA 13, 13D, or 13R calc. You know, it wouldn't make sense to put any of these. So I'm just going to type in residential. Now, minimum desired density. You don't have to put this here, but you can. They have several things in this program that are kind of redundant. You can put it in more than one place, and you don't necessarily need to. And this is one of those. I'm not really trying to think of what would be the advantage, but I'm just going to go ahead and do it. It's going to be 0.05. Why not? I don't know. Sprinkler system type. This is talking about wet or dry, and we're going to be wet. Area of sprinkler operation. Okay, so we're calculating 2 heads at 250 square feet each, so that's going to be 512. I can click in the box, 512 total. Okay, max per sprinkler is 256. That's, again, 16 by 16 spacing. Pretty much any 4.9 K factor sprinkler is going to give you that at 13 gallons a minute. All right, now hydrant flow test date. We'll just put it was today. I don't know why. We're making it up as we go, that's why. Source of info. We'll pretend that we got this from the Portland Water Bureau. And when we get stuff from there, they don't give us a hydrant ID. They give us a simulation ID number, but we'll just pretend that's what the number is we're putting in here. Just gobbledygook. Hydrant elevation we'll say is 0. Now we get to the static, and let's just put in 80, and residual we'll go with 75, and the test flow rate was like 2,000. All right. And I don't, this box is down here in yellow. I think stuff happens in there as we fill in the rest of the calc. You don't actually change those numbers, I believe. I've never have anyway. We're doing a pretty simple calc in this program. There's certain things about this that are a little bit different from other calc software that I'm not really sure why you would want, but for this simple 13D calc, we don't really have to worry about a lot of that, but there'll be a lot of boxes that we'll be going through and just saying we don't have to worry about that. All right, I'm going to go ahead and click on Enter Edit Pipe Data now, and we'll start entering our system. One nice thing about this program is you can kind of go in either direction. Some programs kind of want you to start either at the sprinklers or at the source, and this one doesn't really have a preference. So, you know, if you're coming from another program that does, you know, you can do it whichever way you prefer in here. So that's nice. I'm just going to do it from the sprinklers back to the source at this instance. With Sigma, I would normally go, it's going to require you to input the source first. So I would naturally go from the source to the sprinklers, but I'm just going to do it in this instance with Fire from Elite Software. I'm going to start at the sprinklers. So the first node I'm coming up against here is node 12. And then we're going from 12 to 11. And our default material that we selected was number 13 for Blaze Master Piping. And that's, you know, good. That's what I want here. So I'm going to leave that. And diameter, we're going with 1-inch pipe right here. And then the length of this pipe is 8 feet. And the K factor, we put in 4.9 for the default. So I could either type D for the default, or I could type in 4.9. And 11 also has a K factor, so I'm going to type D again. And so our elevation, if we look at our section here, is 11 foot 1. I'm just going to put 11.1. I'm just going to put 11.1. All right, and let's see, both of these would be at 11.1. Both nodes, and I'm just going to tab through. Area per sprinkler, these are calculated at 256. 256. And we could leave those blank as well because we put in the general information that we were calculating 256, so it would default to that. This sprinkler group, there's really no reason to use it for this type of calc, but it's really for if you're building a bigger calc that you were going to have potentially multiple calc areas in, you would assign those to different groups like A, B, and C. But we're just going to have one calc area, so we could just call it A if we wanted to. Really doesn't matter. Now this is for non-sprinkler flow. We don't have anything. We could also, when we get to where we connect to the domestic plumbing, non-sprinkler flow and GPM, we could put our 5 gallons for the domestic flow that California requires, and most other places. The NFPA 13D requires it in duplexes. This is one way you could add that. All right. There's no fitting, so I'm going to leave that blank. And let's move on to the next line. So the next connection, next pipe is going to be 11 to the top of the riser, which is actually the 7. So I'm just going to type 11 to 7. Again, this type pipe is 13 for Blaze Master CPVC. This is going to be a 1-inch diameter, and we need to add up the length of this piping real quick. So, oops. If I go to my little adder upper here, I've already done it once, but I'll show you guys. Just going to add up all the pipe, oops, from 11 to 4 right here. So 9 foot 1, 2 5, 2 9, 3 2, 6 1, 3 1, 2 6, and 4 foot 0. I'm just going to plug in real quick. 9 1, 2 5, 2 9, 3 2, 6 1, 3 1, 2 6, 4 0. Comes out to 33 foot 1. .08. It's 0.08 feet is 1 inch. That's why I did 33.08. All right. There's no K factor on node 7, just on 11. It automatically brought that down. Since I put 11 in there, it knew that that was a 4.9 K, and in group A, or calc area, it just automatically brought that down. And as I'm passing between here, I'm going to put in 2 T's and 2 elbows, it looks like. One here and one at the top of the riser. So I'm going to put that right here, 2T, 2E. I'm going to go to the next line, which we're going to be looking at our riser. Let me click on this tab. Here is our riser. So right now we left off at a 7. We're going from 7 down to 6, which is where our double check is at. 7 to 6. And so I'm just going to say that this double check is about 4 feet in the air. So we were at 11.1. This is one inch pipe here. Oops, 13. Come on. Not 3. 13. 1 inch pipe. And we're going to go at 7. 1 down. We're traveling. And let's see. So our elevation would be, forgot to set the elevation of 7, would have still been 11.1. Our new elevation here, though, is going to be at 4. And that's it. Now the next one is going to be 6 to 5. And instead of pipe type 13, we're going to scroll up to B for backflow preventer. And it's got 1 PSI pressure loss that automatically came up. But if we look at the cut sheet real quick, we're using a Watts 007. This is the last page. Cut sheet, 26 gallons a minute is going to be right here at 4 PSI of pressure loss on a 1 inch valve, 1 inch double check. So I'm going to change this 1 to a 4, and that's it for that line. Now I'm going to go 5 to 4, and it could just go from 5 all the way to the meter. We don't really need a 4 here, but I like to put one at the base of the riser just because that's what I'm used to seeing it, just the way I'm used to thinking about it. but it really doesn't change pipe type until we get to the meter. So you could just go straight there if you wanted, but I'm going to just account for this elevation loss to go to the floor. So you 1 inch again. And let's see, let's go 3 feet to the floor. Forgot to put the elevation of node 5 was at 4 feet. Node 4 is going to be at 1 foot above the floor. And let's see, next we're going to go from 4 to 3. It's going to be 1 inch pipe. Next tab. Next box, I mean. 1 inch pipe. How long is that one? Let's take a look. It's going to be 48 plus 13. Plus we're buried 3 feet underground, and our last node was 1 foot above the floor. So we're going to have 4 feet of elevation gain that we're going to add to this. So 48 plus 13 is 61. Plus 4 is 65. So I'm going to go 65. Let's see, we're going to have a couple elbows. You tab through, go to here. 2 elbows. And let's go to the next line. That's going to be 3 to 2. And again, we're going to, instead of having type of pipe, we're going to scroll up to meter, or you could just type M for meter. And then it's got 1 in 2019 edition of NFPA 13D, table 4.4a. A 1 inch meter has 3 psi of pressure loss, so that's what we're going to put there. And that's it for this line. And our last thing to connect this, we need to go 2 to 1. And I would prefer that I could put 0 for the city main so that it would match. We could just make it, it's just easier to do uniform across all of our drawings with letting people use different programs, but it won't calc if I make the source 0. It just won't work. So I start with 1. Let's see. So 2 to 1 is 10 feet. Oh, let's see. It's type of pipe is going to be 2 for copper, and the 0.75. Oops. 2.75. And the length is 10 feet. And we'll put, we'll just add a valve and a T. All right, I think we should be good. You know, one more thing with this program you have to remember. I'm going to go in and click in. This is my source, number 1. I'm going to click Mark Inflow Node. Now that I've done that, I should be able to, I'm going to hit Save real quick. And then I'm going to hit Calculation. And when we get to this menu, I go with demand. It's just got this minimum 7 psi and 0.05 automatically filled in here from the cover page. So I'm just going to go with that. And maybe it's just from the last time I ran it. Normally I have to put in a pressure here. I put 0.01 for the imbalance, maximum nodal pressure. And for oscillation damping factor, I put initial damping factor of 4 and minimum damping factor of 1. And this part, I gotta say, is a little bit confusing to me. I don't really understand what's going on here and why or how to change that. But I basically, watched a video from Elite Software a long time ago that said to use these numbers, and it works good for simple calcs. And I've I don't really use this for anything more than teaching people, and I usually just teach with a 13D. And so I have not gotten into these numbers, but apparently you have to play with these a little bit depending on the complication of the system. It may take a very long time to calculate if it's a big system. It may get stuck, those types of things, apparently. So you kind of have to play with these numbers a little bit. But for a house, I've never had a problem with these numbers here working. It seems to always work great. So that's what I always use. So I'm going to go ahead and hit calculate. It shows us here that basically it worked. The calculation was successful. It's giving us, the calculation. If it didn't work, it'd be throwing up some errors now. And so I'm going to go to the print preview to see what that looks like. And we didn't really fill out all of our information, so our cover page is, not really complete. Should have put some more project information in right here. But if we jump ahead, what I really want to see, got a lot of our information in here. As far as jurisdiction stuff that we put in. But what I want to see is the graph. It's kind of the easiest way to me to see if we were successful, and it looks good. We have got supply curve up here at the top and our calculation down below. So it's very clear that we have a successful calculation with a good amount of cushion. That being said, I feel like it's not as easy to see that right off the bat with this calculation when you're looking at it. I had to go to the last page. I'm sure it's on one of these previous pages. I guess what I would like to see is just clearly marked what our percentage of pass or fail was. And maybe it's here, but I'm not seeing it. Anyway, we have a, complete calculation. You can tell it works. And, this will get us a permit. And, by the way, guys, I did this with the test version of Fire. This is not even the paid version. You can do any calculation up to 10 lines with that. And, so you can pretty much handle a 13D project with it. And if you learn how to use it, get you by to begin with, and you might want to purchase the next level up that they have. I think it's $5.99 if I remember correctly, at least at the time of making this video. And, they have higher tiers up from there depending on how many lines you basically need, how many pipes you need in your calc. And so I think that's basically why a lot of people are attracted to this, and as well as the fact that you can just buy it right off their website. Not many calc programs have that option these days. But, with open pricing like they do. But thanks a lot, guys. Thanks for checking out our video on Fire from Elite Software.